Hello, this is my Rube Goldberg project. So let's first see how many steps are in my Rube Goldberg project. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 steps in total. So first, let's see how Newton's first law of motion / inertia is presented in my project. So inertia / Newton's first law of motion states an object in motion will stay in motion unless acted upon by another force. Same goes for an object motionless will stay motionless unless acted upon by another force. So basically, everything is motionless right now. Everything is potential energy. But once I hit this book with my hand, it will be the outside force causing this book to go forward. This book will go forward, causing this wheel to go forward, causing this lever to go forward, causing this pulley / this lever to go forward, causing this lever to go forward because this will pull this. It's a pulley, causing this wheel to go forward, and the wheel will be the outside force causing the lever to go forward. The lever will be the outside force causing this lever to go forward. This lever will be the outside force causing the wheel to go forward. This wheel will be the outside. This wheel will be the outside force causing this wheel / pulley to go into motion. So that is the first law of motion, and I need to look at the second law. The second law is an object's acceleration dependent on forces acting upon it. So if the forces increases, the acceleration increases. So that basically means depending on how hard I hit this book is how far the book will go forward. So the book will go forward. So hopefully it will go fast enough and it'll go forward enough to hit this wheel. Sorry, this is a lever, I forgot to say. But this wheel will go however fast the forces push on it. So if the forces push on the wheel enough, the wheel will go forward down this inclined plane, and depending on how hard the wheel hits the lever is how much forward the lever will go, and that is depending on how much this pulley will go forward, hopefully down to here. And then the wheel will run down the inclined plane, hitting this lever, and depending on how fast the wheel hits the lever is how far and how fast the lever will go forward, and how hard the lever / the force hits on this lever is how far / fast the lever will go forward. Same with this lever, and this lever. Once this lever gets pushed by this lever will go forward, hopefully far enough so that the wheel will go forward, hopefully fast enough and hard enough to cause this to go forward and off of the wall and off of the side, so that this will go upwards, causing my guinea pig to be able to eat his food. So let's see what Newton's third law of motion is, how it's presented into my project. So every action has an equal and opposite reaction / force. So basically gravity is the force. So even though this is up high, it will still go downwards because gravity is pulling it downwards, even though this book is up high, and even though this wheel is up kind of high, even though it's in the air, it will drop down. It will drop downwards, going down this inclined plane because gravity will cause and this hitting this what's it called again? Lever. The lever will go downwards because of gravity, causing this lever to go downwards because of gravity, causing this to go forwards because this is pulling this forwards downward, and once this reaches to about here, it will go downwards because of gravity. The reason why if we jump up in the air and we will go back down, is because of gravity. Gravity, even though we are going upward, we will go right back downward because of gravity is the opposite force. So, this wheel will go downwards because of gravity. Gravity is the force pulling this wheel down, causing this lever to go downwards and hit this lever, causing this lever to go downwards, causing this wheel to go forwards, because even though this lever is hitting it from the back of the wheel, it will still go forwards because because the force is pushing this way, and even though it's hitting back here, it will still go forwards because the force is pushing this way, causing this wheel to go forward, because again the same thing, because even though it's hitting back here on the back of the wheel, it will still go forwards because that is the way the force is pushing. And then it will go forwards and then downwards because of gravity, and the reason why this will go up, even though this is going down, it is still pulling this up because of how the string is made. And then the term velocity, the speed of giving something in a given direction. So basically velocity just means how, like, if I pushed, let's say, this forward, it will go forward because that is the given direction. So if I push this forward, it will go forward because that is the given direction. And the given direction will be forward for this wheel again because it is pushing it forward. And same with this lever, it will be going forward because that is the given direction. And it means like the speed is how fast it will go forward. And the given direction is downwards for this, so it will go downwards fast because that is how fast it will go, as fast as it will go. That is velocity. It will go the same direction as how fast as the force. So like, if I push this forward only a little bit, it'll only go that far in its given direction and as fast as I push it. But if I shift far, it'll go faster and it will stop because of the dresser. But it's the given direction, basically, and how fast it goes. So, and then the wheel will go down fast. It will go down this way because that is the given direction that the inclined plane is going down. So the wheel will go down too, downwards, and then causing this to go forward in the given direction that it has given it. The given direction is forward, and then forward again for this lever because it is pushing it forward, and this lever again is going forward, causing this wheel to go forward again because that is the given direction of the wheel, and the given direction of this pulley is downward and then upward because of how the string is set up. Okay, and then one more law that I have to explain, I'm pretty sure, is the law of conservation. Energy can either be created or destroyed, but converted from one form to another. So, once I push this, it will go downward. And energy, it won't be gone. It'll just be converted into this ball. So, hang on, let me set this back up. So hopefully it will, so when it goes forward, it is not stopped, the energy is not gone, it is just converted into this wheel. This wheel will go forward because it has the energy from the book. And like, so hang on, I forgot to explain. When my hand will not stop having energy because I will still be moving my hand, but the book will stop moving once it falls down, and the energy will be, it won't be gone from the book. It'll still have potential energy, but the kinetic energy will be gone, but it is not completely gone. It is just pushed into this wheel, and the wheel is pushing the wheel's energy into the lever's energy, and the lever's energy is pushing it into this pulley. This pulley is getting the energy from the lever, and this wheel will go downwards and it will push this lever over because the energy from the wheel from the wheel will be converted into this book. And there's another way that I need to explain the law of conservation too, but we'll get to that after. So once it goes forward, the energy from the lever will not be gone. It will be converted into this book. Well, not converted, it will be transferred, and this energy will be transferred into this book, and that will be transferred into this wheel. That will be transferred into this wheel, causing this to go upward because it will be transferred into the pulley. And then also, when it says from one form to another, in my presentation, it will be going from one form to another when everything goes from potential to kinetic. And that is all I have to explain. And now I will show you my project. So here we go.